So much stuff relies on metal joined together, right? Welding.
Mhm.
It's this like hidden network holding everything up. But how do we actually know those welds are any good? That they're safe, built to last?
Well, that's where a whole profession comes in, actually, and that's what we're digging into today, the welding inspector.
Ah, okay. The person whose job it is to check those welds.
Exactly. It's, fundamental for quality, for safety, heavy industry, construction, manufacturing.
Yeah.
Anywhere you find welding, you'll probably find an inspector nearby. But what do they really do all day?
Right. And we got some solid source material for this. Yeah. We're not just guessing.
No, no, we're pulling this straight from guides and standards that outline the typical duties, things like ISO 17637, which is basically the key standard for visually inspecting fusion welds.
Okay, ISO 17637. Got it. So our mission today.
To unpack that material for you, figure out the key roles, the responsibilities, and sort of follow an inspector through the whole fabrication process. What are they looking for? What tools do they need? What does it actually take to say, yep, that weld's good?
I'm actually really curious about this. It's one of those jobs, totally critical, but kind of invisible to most of us. Okay, let's get into it. The world of the welding inspector.
Okay, so fundamentally, the inspector is a key part of the quality control system, the QC system.
Right, QC.
Their main job really is to make sure that whatever's being welded, a component, a whole structure, meets the requirements. And crucially, that it's fit for its application. They're the objective eyes on site.
So it's more than just having sharp eyesight. They need technical chops, too.
Oh, absolutely. A deep understanding of QC procedures is vital, yeah, but also sound welding technology knowledge. They really need to get how a weld should be made, the science, the potential problems, not just what the final thing looks like.
And visual inspection, that's their main tool, isn't it?
It's one of the main non-destructive examination disciplines, NDE.
NDE, right.
Sometimes, maybe for simpler stuff, visual might be the only NDE needed. But for anything high integrity, think pressure vessels, critical pipes, bridges, visual, is always the first critical step.
Always the first step.
Always. Then it's often followed by other NDT methods, non-destructive testing. Things like liquid penetrant or magnetic particle tests for surface cracks, or maybe ultrasonics or radiography for stuff hidden inside the weld.
Oh, okay.
But if the visual inspection fails, if the weld looks wrong on the surface, the other tests might not even be useful or even possible.
Got it.
Yeah.
So visual is foundational. You mentioned standards. Does the main rule book for, say, building a bridge tell the inspector how to do that visual check?
That's a great question, and it points to an interesting split. The application standards or codes, the ones for the bridge itself, for example, they do define the acceptance criteria, what counts as a defect, how big it can be, that sort of thing. But they usually don't spell out the practical details of how to conduct the visual inspection itself.
Huh. So where does that come from?
That's exactly where a standard like ISO 17637 fits in. It's the standards for the method.
Ah, okay. So ISO 17637 is the how-to for visual checks.
You got it. The full name is Non-Destructive Examination of Fusion Welds Visual Examination. It gives the essential requirements, the guidance. It covers like who's qualified, the lighting conditions, the tools, how to record stuff, even when to inspect during the job. It's the real backbone for doing it consistently.
All right, let's break that down, starting with the inspector themselves. What does ISO 17637 say they need?
Well, first off, they need to be prepared. Before they even start inspecting on a project, they have to be totally familiar with all the relevant standards, codes, rules, specs for that specific job.
Okay, do their homework.
And they need to know the welding procedure specifications, the WPSs, inside out. Those are the welder's instructions, basically.
Yeah, makes sense. And I'm guessing good vision is a must.
Oh, absolutely critical. It's not just assumed either. The standard points towards norms like EN 473 in Europe. Other places have similar ones, which require vision tests, specifically visual acuity, checked every single year.
Every year? Wow.
Yep. You just can't inspect tiny flaws if you can't see them clearly.
Definitely. Now, does the standard say you need like a specific visual inspection certificate?
That's actually a really interesting point where the standard itself and what happens in industry aren't quite the same. ISO 17637 technically doesn't mandate a formal qualification just for visual inspection.
Oh.
But in practice, out in the real world, the industry pretty much expects inspectors to have solid practical experience plus a recognized broader welding inspection qualification.
Like what?
Well, the source material mentions things like CSWIP That's the certification scheme for welding and inspection personnel. It's known globally and covers way more than just visual.
Okay, so CSWIP is an example.
Yeah. So while the standard sets a baseline for the task, industry usually demands a higher qualification for the overall role of welding inspector.
Gotcha. Standard sets the floor, industry expects more. Makes sense. Beyond the paperwork and the eyesight, what about, the personal stuff? What makes a good inspector?
The source highlights this, and it's really key for trust and just being effective. Honesty and integrity, they're number one. You have to report what you find impartially, even if it causes delays.
Yeah, that takes guts sometimes, I bet.
Definitely. Deep knowledge, practical knowledge, not just book smarts. And being a good communicator. They need to explain findings clearly to welders, engineers, everyone, and document things properly. These qualities are, well, essential.
Absolutely, especially when safety's on the line. Okay, let's shift to the setting, the environment, the tools. What conditions do they need?
Conditions are super important. Bad light, awkward access, you can miss things. So illumination, the lighting is specified. ISO 17637 says a minimum of 350 lux.
350 lux, what's that like?
I think maybe slightly dim office lighting, but the recommendation is actually 500 lux.
Okay, and 500 is?
That's more like your standard office or a well-lit workshop floor, bright enough to see details easily without straining.
Right. And access. You can't inspect from across the room.
No way. For direct viewing, the rule is your eye needs to be within 600 millimeters, about 2 feet of the surface.
Okay, close up.
And the viewing angle should be less than 30 degrees to the surface. This helps you see the weld shape, the profile, and spot any shallow defects. The source even has a little diagram showing this close-angled view.
Good light, close distance, right angle. Got it. What about gear? What's in their toolkit?
It's a mix, actually. Some specialized stuff, some everyday tools. If they can't get direct access, maybe for inside pipes or tight spots, it might need things like mirrored borescopes or fiber optic systems. That's usually agreed on beforehand, though.
Okay. Specialized viewing tools.
And auxiliary lighting, like a good flashlight or torch, is often essential, even if the general area is lit. It helps create shadows, contrast, makes features pop.
And measuring tools. What are the must-haves?
Welding gauges are absolutely key. These aren't just rulers. They're shaped tools for specific measurements.
Like what kind of measurements?
Well, you've got bevel gauges for checking the angle of the plate edge before welding, profile gauges for the final weld shape, fillet weld gauges to measure the size of those triangular welds, gauges for undercut depth, even gauges for checking the gap before welding.
I think I've heard of high-low gauges, too.
Yep, those are vital. They measure linear misalignment, high-low, making sure the edges of the plates line up properly before they're joined. ISO 17637 actually shows pictures of these and specifies how accurate they need to be.
So really specific tools for the job. Anything else notable?
The list includes things like straight edges, measuring tapes, maybe a magnifying lens, specifically X2 to X5 magnification if used.
Oh.
Also, temperature indicating crayons.
Crayons for temperature.
Yeah, they melt at specific temperatures so you can check preheat. Also, a voltmeter, ammeter to check the welding machine settings. Maybe a gas flow meter for the shielding gas. It's a real combination.
It really shows how inspection blends careful looking with precise measuring. Okay, so inspection happens as welded minimum, but for the big critical stuff, it's more continuous.
Exactly. While the standard ISO 17637 focuses mainly on the final visual check, industry practice, especially for high-integrity stuff like pressure systems or major structures, demands inspection throughout the process.
Right. You can't wait till the very end.
No, finding a major issue in the root weld when the whole thing is finished is, well, it's bad news. Very expensive. So inspection happens throughout.
Makes sense. Catch problems early. So how is that structured?
Typically, the inspector's duties break down into 3 main phases, following the actual work: before welding, during welding, and after welding.
Okay, before, during, after. Let's walk through it. What's happening before welding even starts?
Right, this is all about prep and checking everything's set up correctly. First, the inspector needs to be fully up to speed on the documents. The standards, or code for acceptance criteria, the drawings for dimensions, the company's own QC procedures, and any specific quality plans for this job.
So making sure the plan is solid and everyone knows it.
Exactly, and part of that is understanding terms like good workmanship standard. This isn't always a hard number, right? It's about the expected quality for things like how clean the prep is or how the tack welds look. It can depend on the application, the client, maybe even reference samples they agree on.
Ah, so there's some judgment involved there based on experience.
Definitely. That's where the knowledge and integrity really matter.
Okay, so what are some specific checks they do before the arc is struck?
Oh, there's a whole list. Big one is materials. Are they the right type and grade? Can they be traced back to their test certificate? Are they clean, no rust, oil, paint, whatever? Using the wrong or dirty material is a recipe for disaster.
Can't weld junk, what else?
They check the WPSs, the
Mm.
welding procedure specifications. Are they approved? Are they actually available to the welders and the inspector? They check the welder qualifications. Is the person doing the welding approved for the specific procedure? Is their certification current?
So checking the paperwork for the materials, the procedure, and the person, what about the actual setup?
Right. Consumables, the welding wire, electrodes, gas, correct type, stored properly, handled properly to avoid contamination. Then, the weld preparations themselves. Do the angles and gaps match the WPS and the drawing? Are the edges clean? No defects.
Checking the actual joint prep.
Yep. And the welding equipment is in good condition, calibrated. They check the joint fit up, how the parts align. Are the tack welds okay?
Tack welds.
Little welds just to hold the parts together before the main welding. They need to be done right, too.
Okay. Anything else before they start?
Preheat. If the WPS requires heating the metal before welding to prevent cracking, they check that the minimum temperature is reached. They also check their own inspection tools are okay. And finally, safety. Aware of the rules, necessary safety gear available.
Wow, that is a lot just to get ready to weld. Makes you realize how much goes into a good joint. Okay, prep is done. What about during welding?
This is all about monitoring the process live, catching deviations as they happen.
Like what?
Well, if it's site welding, first check the weather conditions. Can't weld unprotected in rain or high wind usually. They confirmed the welding process being used matches the approved WPS. Is the welder actually doing what the procedure says?
Okay. Making sure they stick to the plan.
And confirming the welder doing the work is approved for that WPS. Then a really critical one, monitoring temperatures. Making sure the minimum preheat is maintained between passes, and this is vital that the maximum interpass temperature isn't exceeded.
Interpass temperature. What's that?
It's the temperature of the weld area just before the next weld bead is laid down. If it gets too hot or too cold between passes, it can mess up the metal properties.
Ah, okay. So keeping it in the right temperature zone.
Exactly. They also check the consumables again, right ones being used for this pass,
Yeah.
handled correctly. And they might check the welding parameters, using a clip-on ammeter or voltmeter to see if the amps, volts, and travel speed are within the ranges set by the WPS.
Checking the machine settings, basically.
Yep, those settings directly control the heat input and weld quality.
What about the actual weld bead being laid down?
Absolutely. A key check, especially for pipe welds or anything welded from one side, is the root run inspection.
The first pass.
Exactly. They need to visually check that first critical layer before it gets buried by the next ones.
Yeah.
That's where problems like lack of fusion or root cracks often start, and it's much easier to fix then.
Makes sense. Catch it early.
They also watch any gouging or grinding, making sure it's done properly. Check the cleaning between passes, getting rid of slag. And maybe keep an eye on distortion control, making sure the welding sequence isn't causing the whole thing to warp badly.
It's really like overseeing the entire operation step by step. Okay, check to pour, monitor during. What's left for after welding?
This is the final check and documentation stage. First, weld identification. Make sure the weld is marked, usually with the welder's ID, and it matches the drawing or weld map, so you know who welded what.
Traceability.
Crucial. Then comes the big one, the full visual inspection of the finished weld.
This is where they give it the pass-fail.
Pretty much. They sentence the weld. They look at it closely. First, is the surface okay for any other NDT that might be needed? Then, they examine it for defects, undercut, porosity cracks, wrong profile, whatever, and compare what they see against the acceptance criteria in the code or standard.
Judging it against the rule book.
Precisely. They might also do a dimensional survey. Check the final dimensions of the whole assembly against the drawing, because welding can cause distortion.
Okay. Does it fit?
Right. They confirm any other NDT, like ultrasonic or radiographic testing, has been done and the reports are in. If repairs were needed, they monitor the repair to make sure it follows the approved procedure.
So they check the fixes, too.
Absolutely. And they oversee things like post-weld heat treatment or PWHT,
PWT.
heating the whole thing up after welding to relieve stress. They check the furnace charts to make sure it was done correctly. Same for any pressure tests or load tests, monitor them. Check the records.
So overseeing all the final checks and tests, not just looking at the weld surface.
Exactly. And all of this culminates in perhaps the least exciting but most critical part, documentation.
Ah, yes, the paper trail. How much detail is needed there?
It really varies. For simple stuff, maybe just a signature on a checklist saying, yep, inspected, no formal report needed sometimes.
But for the important jobs.
For critical work, yes, a formal inspection report is usually required. ISO 17637 gives guidance on what should be in it. Things like who made it, what the item is, material type, thickness, joint type, welding process.
The basic details.
Right. And then, critically important, the acceptance standard used, what rules were applied, and details of any imperfections found that were not acceptable, where they were, what type, maybe a sketch or photo helps. And of course, it needs the inspector's name, signature, and the date. It's proof of inspection.
That ties right back to those 3 core actions you talked about earlier, doesn't it? Observe, record, compare.
It absolutely does. The whole job really boils down to that. Observe everything relevant that affects weld quality, from the very start to the very end. Record the inspection findings, especially any problems, and compare everything observed and recorded against the requirements, the standards, codes, drawings.
Observe, record, compare. That really sums it up. So putting it all together, the welding inspector isn't just glancing at a finished weld. They're embedded in the process, ensuring compliance from planning through execution to final testing. It takes, well, a lot of technical knowledge, crazy attention to detail, and real integrity.
They really are that essential link. The person making sure the engineering and the skill translate into something safe and reliable that, we all count on.
Thinking back through all this, what really stands out to me is that mix you described. On one hand, you've got these very objective, measurable things from the standards, the lux levels, the 600 millimeter distance, the gauge measurements, the temperature limits. Very black and white. But then you have these other areas, like judging good workmanship, or if material is in suitable condition. That sounds more gray.
It is, and that's a fascinating aspect of the job.
Yeah.
How does a good inspector balance those? The hard rules from the book versus the judgment calls based on experience, context, understanding the application. It really highlights that while standards give the framework and tools give precision, it's the inspector's knowledge, their experience, and their integrity that ultimately ensures a weld isn't just compliant, but actually fit for purpose in the real world.